is a very important construct in Python. It really does help us write better programs, organize our programs better, and just makes our program all the way easier to manage. And the point is, what exactly are functions? And as you can see here, they're actually reusable blocks of code that perform specific tasks. So if there are specific tasks you want to perform, you can actually just arrange them in these little blocks that you refer to as functions, and then you can call them at any time you want without having to rewrite them over and over and over again. So that's essentially what functions are and what they do. So I'm going to go into a little more detail about what functions are, and eventually would look at some code that really shows what functions are and how they are used. So I would, as you, given what you have on the screen, it says something like a function is a reusable block of code that performs a specific task. Another way to look at it is that it's a mini program that lives inside your program. So a program within a program. So today we are going to be focusing on Python functions. Functions in Python are really, very important. It's a very important construct in Python. It really does help us write better programs, organize our programs better, and just makes our program all the way easier to manage. And the point is, what exactly are functions? And as you can see here, they're actually reusable blocks of code that perform specific tasks. So if there are specific tasks you want to perform, you can actually just arrange them in these little blocks that you refer to as functions, and then you can call them at any time you want without having to rewrite them over and over and over again. So that's essentially what functions are and what they do. So I'm going to go into a little more detail about what functions are, and eventually would look at some code that really shows what functions are and how they are used. So I would, as you, given what you have on the screen, it says something like a function is a reusable block of code, right? Say reusable block of code. Let me drop this lower. So it's a reusable block of code that performs a specific task. Another way to look at it is that it's a mini program that lives inside your program. So a program within a program. And then when you want a task done, right, what you do is you essentially call the function that performs that specific task. So if you remember, when we started off, with the Python course, one of the first things you immediately saw was the print function, right? And I had alluded to the fact at that point that the print function, right, is a function, some kind of inbuilt function within Python. Even though all you see is print, and I'm going to talk about that a little more in the coming slides, there's actually an underlining code behind it. So when you write print parentheses, all you're actually doing is you're calling that function, right, to perform a certain task. And the way I described it at the time was, think of the print function, or the function call that you can see here. Think of it like the pedal in your car, right? It's an accelerator. The power that drives the accelerator is not within the car, it's somewhere else in some whatever number of horsepower engines there are. But all I need to do to call that power from that engine is just to tap on my accelerator, right? And then your car will rev and it will move. And you can literally control at what speed your car is moving by simply tapping down or releasing your feet, right, from the accelerator. So it's a form of abstraction where you actually hide away all of the complexity about a code and just use a line or a particular word to make a call for that power or to make a call for that functionality to come to life. So what we have here are a couple of inbuilt functions within Python. If you remember input, once you use input, all of a sudden it throws up some kind of dialog box or a form asking the user to put in information. Length is where I'm trying to find out the length of a particular string or whatever. And these are all different types of functions. Range, you see a particular time where I'm trying to get certain numbers within a range, right? So these are all examples of functions, but then there are two separate types of function. There is the inbuilt function, and then you also have the user-defined function. Now, Python has done all of these for us, but what happens if there is a function I want to create, right, that Python has not created yet? Right? Or something where I want to get a bunch of things done. These are not universal demands. So Python, of course, wouldn't go create those things, but you need it specifically for your program. What do you do and how do you create it? And that's exactly where your user defined functions actually come in. So essentially two types of functions, the built-in functions, which are already provided by Python, and below are some examples. And then you have user defined functions. I just gave one of them there, but you can create any number of functions as your user defined functions. So I was talking about print, right? Conceptually, that print function, what you have here as just print, you know, these are all the things it does. It takes an object that you pass to it. So when you do something in a code, right, you end up with some kind of object. You pass that object in, then the code, what it does is that it converts that object to text. And then those objects that have been converted to text, it kind of joins them together using sept, right? And then it adds every one of them, right? Then next thing it does is that it writes that result to a file, and then it kind of just prints it out. That's exactly what kind of generally what print will do. Now, this is not the exact print function, but it's something that essentially does the kind of things that the print function will do. This is def, which is, and we're going to come to this. This is a particular keyword that is used to initiate or to say, hey, this is a function, and then this is the function name. And then these are the parameters inside the function, right? And then you import sys, which is some kind of system, what do you call it now? System function that is required to run all of this. And then this is the body of your text, right? And then you just go down, and that's how you get all of what I described here accomplished within this text. So like I said, this is not the actual C Python source code, right? But it's a very close model of the behavior documented by print. But why am I actually talking about all of this? I'm just saying all of this to mean that when you see print, print doesn't stand alone. It has something underlining that is driving it and making it possible, right? You have to do each of these operations sequentially to get to some kind of answer. So you have a code that is something along the lines of this, but each time you want to use print, you don't have to do all of that. You just go write print, open and close parentheses, your parentheses, and that's it. The print function is built into Python's interpreter in C, and its main job is to convert objects to text and then to write them to the output stream. So get the object, convert it to text, arrange it with sept and an end up to end, right? And then you write them to the outstream code, and that's what it is. So this is an example of what we have here, right? I have a variable name, right? And I have input. Input essentially is just going to throw up. This is another function right here. So it makes a call to input. Input will do what it does, and then it will pop up what is your name to the user. And then the user will type in their name, and then you now use your print function. Immediately they type in their name, which, for example, if the name of this person is Ken, this pops up. Ken types in Ken. Now that Ken is mapped to name immediately because it receives it and maps it to a name. And then the next thing that happens is you have another function call here, and then it says hello, and then it pulls this variable, the content of this variable, right? And then into this place, and all of a sudden it will print it out. And then I can do something else where I say print I do a second function call. So, but if I hadn't used this, I would have like 10 lines of code. And then for the second function call, I'll have another 10 lines of code, but I abstracted all of those complexity out and just used this. And now I have print, your name has, this number of letters. Now I'm trying to use another function within that function to figure out the length of that name, right? And this will do what it does, which is this function, connects with the body of that function and executes whatever task that has been said there. And that's how we are able to figure out the length, because that's what len does. It finds out the length of um, that particular name that has been input, which is a string, and then all of a sudden it tells us, let's say for Kelvin, Kelvin will be 6 letters, Kelvin. So it will say your name has 6 letters. But how does it find this out? It's a function that just goes back there and does what it does. So instead of rewriting the same code each time, you simply call a function again, and this is called like a function call. So each time you use that shorthand, right, to draw up power, draw up, functionality from the abstracted code, that thing you're doing is what we refer to as a function call. So I would show you this. So essentially a function call is the act of telling Python to run a function. Go there, figure out where that function is, and please run the content of that function. So as you're looking at this, right, this first box is actually a function, right? So, and how you know it's a function is def. That's the reserved keyword that is used to initiate a function. This is the function name. And we're going to look at the syntax again as a review of a function. This is the function name, and what we have in this box is what you refer to as a parameter. You could have multiple parameters, right? And then, of course, this is our system created function. So it's literally a function within a function, and then all of these put together is what you refer to as your function, right? Or you can aptly refer to it as a function of functions. So this is your function. So the point is, if I want to call this function, how do I call it? The only thing you need to do to call a function is just go use this, which is the name of the function. Like in print, right? Print is the name of the function. In this particular function, greet person, greet underscore person is the name of the function. So if I want to call this function, all I need to do is come in here and I'll say greet underscore person. But notice what's happening here too, right? Inside the parentheses, all of a sudden, I can, you know, decide what will map to the parameter. And this thing that would map to the parameter is what we refer to as an argument. So for a program like this, if I say greet underscore person and I put in quotation marks, and of course, um, put parentheses and then inside it my open and close quotation marks, which makes it a string, right? This name is going to map to this. So this particular thing we have here is what you call the attribute. This is the attribute and this is the parameter, and this will map to this. So if you decided to print this out, right, this is what you're going to get, right? Greet person, noble, right? It will just come here and execute this function, which is hello, noble, hello, Sarah, hello, David. That's what it does. So this here is the function, and this here are the function calls. In other words, it called this function 3 times. Now notice that this function has only 2 lines, right? And this is 1, 2, 3. If I was trying to write all of this, I'll have to write this 3 times. Then you have 6 lines. But this is a very simplistic one. There are functions that have 20 lines, right? Because you're trying to execute something and still you can just call it with one. You can call it through what we here refer as the function call. So parameter, argument, parameter, argument. So the relationship between parameter and argument is almost like the relationship between a variable and a value. Or in dictionary, right? The key and the value. It's literally the relationship between them, sort of. So this is a specific example where one function is called multiple times with different values, and these are the values. Those values are referred to as arguments. So, which brings me to this. A parameter is a variable within a function, in a function definition or within a function definition, while an argument is the actual value given to the function when it is called. That's very important. So here is an example, right? I said I'm trying to add numbers, right? And I want to create this thing where I don't want to keep writing the code of how to kind of add a bunch of numbers, right? So I come up with what I would refer to as, I would say something like, I start with my reserved username, my reserved name, which is def. That initiates the start of a function. Then this is my function name. These are my parameters, right? And then this is the body, which is the actual action I want it to perform. I want it to print A plus B. In other words, anytime I put in some kind of number that is A and some kind of other number that is B, I want you to add those two numbers, A plus B. So this is me making a function call. I use the function name and I'll be like 4, C. All it does, it maps this. A now becomes 4, B becomes 6, right? And once you just do that, all of a sudden, your output is going to be something like 10 because it is 4 plus 6 that will give us 10. And then I can do any number of numbers. I can decide I say 4 billion plus 6,000. and it will do the operation without blinking an eye. So in this particular case, A and B are parameters, 4 and 6 are arguments. So essentially, you map your arguments to your parameters, and that's how you get your results. So essentially, using functions makes programs easier to write, easier to read, easier to test, and also easier to debug. In the particular case of debugging, imagine if I had to write these lines of code. Let's say a function has 10 lines, and I need that function to be called 20 times within a code that I'm writing. Then I'll have to put those 10 lines everywhere, which will now be 200 lines, right? Anytime I want to make any change, I have to go to those 20 different instances to make that correction. But if I modularize this solution, right, where I abstract the function somewhere, anytime I want to make a modification, I just have to make a modification to just that one code, right? And the result will replicate anywhere there is a function call. So even though we've already gone through this, but this is the basic syntax of a function, which is def, which is your reserved name that you use to say, hey, I'm about to create a function. Then you have some kind of function name, and this function name can be anything, but this is a preferred way of writing a function, and it can be written any number of ways, right? And then you have your parameters, and then this is where your body is, which is where you're actually putting together the instructions that you want it to execute, and then it kind of returns some kind of result. So as in this case, right, this is the syntax. Def, right, it defines a function. Function name, that's the name of the function. Parameters, the inputs to the function. Then the body, this is your body, which is the code inside the function. That's the brain of the operation. And return actually helps send the results back. That's essentially what the components of a function are. So this here is another example. Def, right? Greet, the username in this particular, the function name is greet, right? And then this is the parameter. Then this is the actual instruction of what to do. It says print hello, then the name, right? Then how do I make the call? I make the call by just writing down the function, and then what the argument I want to map to this parameter, I write it out there. And guess what? If I did that, this is what it will print out. Hello, Alice. So this is supposed to be hashtag, and this is not percent, it's hash, the hash. So this is supposed to be the comments. This is the function definition and name. This is the body, and this is the call to action. So this is a typical example, again, of a function. And so that's where I'm going to stop with this. And we would continue